Hi guys, today's video is going to be over divergent plate boundaries. So let's note that real quick. We're talking about divergent plate boundaries. And as you already know or have learned through the last couple of days, this is an area where two plates meet. So let's say this is the boundary between the two plates. And the plates are moving away from each other. All right, so we want to look and see where is this actually occurring. And our first example, excuse me, is going to be mid-ocean ridges. So this is occurring along mid-ocean ridges. And this is also known as what Harry Hess and Fred Vines called seafloor spreading. If you have your plate tectonics map available, then go ahead and pause the video real quick and go get it, because I want to indicate on that map where this is happening. So if we look at our map, and y'all had put your arrows in yourself, I'll add this one to our page if you need to print out this one. But you can see where the arrows are moving apart. Here you have the North American plate carrying North America, part of the Atlantic, some of the Pacific. Here you have the Eurasian plate also carrying some of the Atlantic Ocean here. African plate carrying Atlantic and Indian Ocean. South American plate with South America, and here is the Pacific Ocean. So in the middle of the Atlantic Ocean, there is a crack. That's a divergent boundary, right? Remember, our lithospheric plates are cracked. So this is the crack here in the middle of the ocean. You see arrows are indicating that this is separating. These two American and Eurasian plates separate at about a rate of 3 centimeters per year, which is about what my fingers indicate at this time. So they are moving away from one another. And that's very important to note. Also, if you look over here, here's South American plate. Here's the Nazca plate. The Nazca plate is actually under the ocean, as in most of the Pacific plate. Here too, you're going to see boundary where the plates are moving apart here. So that's why we call them mid-ocean plates. Most oceans have an area where they have seafloor spreading going on. All right, so what does that really look like? Well, I made us a little virtual model here so we can kind of use this as our model. I hope it works. It's going to work. So here's the Atlantic Ocean, and literally the crack between my two boxes is the crack here, or the mid-ocean ridge. This one is the mid-Atlantic ridge because this is the one in the middle of the Atlantic Ocean. So we're going to label this the mid-Atlantic ridge. And that's this. If you look at what plates I've drawn in, I've pretty much drawn in here. This is supposed to be the North American plate, so we're going to label it North American plate. Here is the South American plate. Here is the Eurasian plate. And down here we have the African plate. So these here, these other lines are just going to be kind of where those plates separate. And then of course the mid-Atlantic ridge This is a divergent boundary, meaning this is moving away from each other. So it's separating North America and Eurasia, South America and Africa plates, separating all those plates. So what's happening here? So as these slowly move apart, what is below these lithospheric plates? Well, we know below the lithospheric plates is the asthenosphere. So in that asthenosphere, this is where we have those currents that are moving the plates. Remember, like a conveyor belt, they must be moving in this way along the actual boundary because the plates are moving away from each other. And what's coming up as they are getting moved away from each other is new oceanic crust. So this is an area that creates new crust as the plates move apart, because the ooey gooey magma from the asthenosphere down here, that red part, it's coming up and creating new oceanic crust. All right, let's move our model out of the way for our plates. And so this is our mid-Atlantic ridge, that is, or a mid-ocean ridge. And this one specifically the mid-Atlantic that we've been talking about. So we're going to add example is a mid-Atlantic ridge. What's happening? New crust is being created, new oceanic crust. Created along boundary. Now, a drawing to go along with that. Let's put us a drawing in our notes so that we have that information as well. So I'm going to draw my lithosphere and my other plate here. So this is going to be my North American plate. And this is going to be my Eurasian plate. Remember, North America carries continent and ocean. So let's draw in some water here. As does the Eurasian plate. The Eurasian plate carries ocean, as you see, and then continent as well. Okay, that's my ocean. So we're in the middle of the ocean. Here we are. And we know that our convection currents, let's first label these as lithospheric plates. Okay, and so we can see what's coming up. So what rises? Warm, ooey gooey magma, or cold? Well, remember that warm rises because it's less dense, and cool sinks. So right along here, and we know this because these two are moving apart, we know that the convection currents must look something like this. So warm is rising here along the boundary in the asthenosphere, and cool ooey gooey magma is sinking. As it cools, when it hits the lithosphere, it sinks again, right? So let's note that convection currents in the asthenosphere are pushing plates apart. Remember that in the asthenosphere you got that ooey gooey magma. Some people refer to this as plasticity. And all their meaning is it's ooey gooey magma. It's not a solid, it's not a liquid, it's kind of between the two, so it has a capacity to move just like a fluid, and that's why warm rises and cold sinks. Now, of course, we just said that this asthenosphere, what's going on here in the asthenosphere, is moving the plates apart, but also allowing for that ooey gooey magma to creep up and make new ocean floor. So this is new ocean floor, if you can believe that. So I'm going to label that too. Where can I label that? Over here. So creating new ocean floor or crust. Okay. All right, so that's one part of this lesson. So that's what's going on beneath the ocean floors. Now we need to look a little bit further into this, because what happens if the plate boundary, a divergent plate boundary, one that moves apart, is underneath a continent? And that does happen, and we're going to go back to our map for a minute. So looking back at our map, and I kind of messed this one up. You can't really see what I'm talking about, so let me get another one of these. I just happen to have one. So let's go back here to our mid-ocean ridge, or mid-Atlantic ridge specifically, which is this one, right, moving apart. Well, you can see right here, there's a little piece of land, a little continent there, or sorry, a little country there, and it's known as Iceland. So this right here is Iceland. Where is it? There it is. That's Iceland. And Iceland just happens to be formed right on top of a plate boundary. So you can see the boundary runs through Iceland. Well, what is happening there? Well, in the case where a boundary runs beneath a continent, we refer to this as creating what's known as a rift valley. Okay, so if you look over here in Africa, the same thing is happening here too. You see the lines for this plate boundary. You see they are also divergent here. And let me see if I can get that. They're divergent here, and they are moving apart, and this goes right through Africa. This is Africa. This is part of Africa continent. So right in here, you can see that, and if you pay close attention, there's ocean that has now formed right here. Because this part of Africa, Saudi Arabia, which was once totally attached to Africa, is now spreading away or moving apart. So this is another rift valley here, because Saudi Arabia one day will no longer be a part of the African mainland. It has already started separating by the Red Sea. So what happens when Iceland is totally separated? Well, yeah, ocean water from the Atlantic will fill in that crack, and then there'll be Iceland 1 and Iceland 2, I guess. I don't know what they're going to name it. But so when these types of boundaries, divergent boundaries, occur beneath the continents, then you will have what is known as rift valleys. So we're going to note that on our notes. So we had mid-ocean ridges, and we have, what else does it create? Rift valleys. An example is Iceland. Another example is the East African Rift. Zone or valley. Remember, this is separating Saudi Arabia from African mainland. And in Iceland, it is separating Iceland into two lands.